Thanks, Tom. And my presentation is about the red wolf, but it's not really about the red wolf. It is about illustrating a concept using red wolf data. What I want to talk about is how mitigation along major highways can be a priority, but it is not necessarily sufficient if you have conservation goals. So what I want to recognize is that we received funding from US Fish and Wildlife Service to conduct this project. Red wolf was once common in what now is the southeast and eastern United States, but intentional killing and habitat destruction led to extreme range contraction. By 1972, the species was only present on the border between Texas and Louisiana. And then US Fish and Wildlife Service started to remove these animals, the remaining animals, to start a captive breeding program. By 1987, a start was made to reintroduce the red wolf in and around Alligator River National Wildlife Refuge in North Carolina. And most recent population estimate from February this year is about 20 individuals, less than 20 individuals alive in the wild. But there's 270 in captivity, and they are used to introduce new animals. Now, this graph on the left-hand side, if you focus on that solid black jagged line, that shows you the growth in the population size of the wild red wolf population since 1987. So there was a steep increase in the population size starting in 87 until the mid-2000s, and then leveled off at about 100 individuals present in the wild. Starting in 2013, a steep decline was associated with a limitation into how US Fish and Wildlife Service was allowed to manage the red wolf population. The bars for each calendar year, they indicate the major sources of known mortality. And when you look at the data on the right-hand side, it shows you that gunshots and vehicle strikes are the leading causes of known mortality. Depending on how you calculate it, each between 20 and 26% or so of the known causes of mortality. If you look at vehicle strikes, this represents about 5 to 6% of the population being killed by vehicles every year. Now, if you want to have the population rebound from the 20 individuals or so that we have now, and if you want to do that through reducing unnatural sources of mortality, then these are the things to look at. It's already illegal to shoot a red wolf, but where we can make a benefit, progress still, is by reducing the vehicle strikes. And that is what I'll focus on. So this map shows you Alligator River National Wildlife Refuge, more or less in the northeast corner, and its surroundings. And the green, yellow, and red blobs indicate where we've hit red wolves with vehicles over the last 2 decades since they were reintroduced. When it's immediately clear that most of the collisions have happened on US Highway 64, the road section that cuts through Alligator River National Wildlife Refuge. What I want to focus on in my talk is compare a traditional approach where we would be focusing on mitigating the busiest highways versus an approach that has a conservation goal. When you have a conservation goal, it's often not sufficient to focus on a line in the landscape. Conservation takes place in the larger landscape, and it includes other roads, including low-volume roads. It's the same map with the hotspots of where we've hit red wolves over the last few decades, but the numbers now indicate the traffic volume, the annual average daily traffic volume, how many vehicles drive on each road section on average per day. It's clear that Highway 64, we have a pretty high traffic volume, around 4,000 vehicles a day, at least relatively speaking. But many of the other hotspots of red wolf mortalities are along lower volume roads. What we did is we looked at each 1/10 of a mile road length unit and assigned the associated traffic volume with that 1/10 of a mile road unit. So we knew how many 1/10 of a mile road sections do we have that fall within a certain traffic volume category. The traffic volume categories are on the horizontal axis here. So when you know how many you have in each traffic volume category, then you can calculate how many red wolf mortalities you might expect if the mortality is independent from traffic volume. If the mortality is independent from the traffic volume, you get the ratio observed versus expected of 1, and that's that solid horizontal line. Now, what you see here is for the traffic volume category 2,500 to 5,000 vehicles a day, we're hitting 2.3 times as many red wolves as you would expect if the red wolf mortality would be independent of the traffic volume. Now, that means that we can implement mitigation there in a relatively efficient manner. For a relatively short road section, we can mitigate a substantial portion of the historic red wolf mortality. We get a disproportionate return on our investment. That's obviously not only the only traffic volume category where the road mortality is happening. It's also predominantly happening in roads under 2,500 vehicles a day. However, if you mitigate those lower volume roads, you only get a proportional return on your investment, meaning you mitigate a mile of road and you get a proportional return in terms of reducing red wolf vehicle collisions. Looking at the same data in a different way, again, we have the traffic volume categories on the horizontal axis, but now on the vertical axis, we have the absolute number of road-killed red wolves. And when we look at how they're distributed over those traffic volume categories, under 5,000 vehicles a day, that is where 92% of the historic road mortality has happened. If you would implement mitigation only along the busiest highways, say 2,500 and more, this includes US Highway 64, you would only mitigate about 27% of all historic road mortality over the last few decades. If you have a higher threshold, only 5,000 vehicles a day or more, it is only about 1%. So it's clear from this graph that mitigation, if you want reduced road mortality to contribute to a rebounding of the population, you would have to also focus on the lower volume roads. There's also a different way of looking at red wolf conservation in relation to roads and traffic. And that is through where we have data on historic birth locations. Where are red wolves born in the wild over the last couple of decades? And that is shown by the red blobs on this map, concentrations of birth locations. If you go to the northeast, Highway 64, you see in that area we have a number 4, and it says we have 4 concentrations of birth locations of red wolves south of Highway 64. But north of Highway 64, we have 0. So this tells us we don't have high quality habitat or not enough high quality habitat to have resulted in birth locations over the last few decades. And while mitigating that road section can be very important to reduce road mortality, it doesn't connect to high quality habitat north of the road. On the other hand, we have Highway 94 in the smack center running north-south. Now we have west of the road 7 historic birth locations, concentrations of birth locations, and northeast 2, and towards the southeast and the far east, we have 4. So this is where we can connect historic birth locations, can connect apparently high quality habitat. Still looking at birth locations, we again use those tenths of a mile highway segments, and we counted up to 1,000 meters from each road segment how many red wolves have been born over the last few decades within that radius. And the highest concentrations are circled in red. Look at the northeast, Highway 64 and also Highway 264. This is the Milltail area. This is also where we have the last remaining breeding pair of red wolves. That is where we would be able to protect the breeding adults and their offspring. If they do not survive, if they get killed on the road, the population can't grow and the juveniles can't disperse. If we keep them alive, the population can grow, the juveniles can disperse. So it makes sense to protect the breeding adults and their offspring. But historically, there were also other locations with concentrations of breeding adults and their offspring. And they are not only along high volume roads, a few hundred vehicles a day, even a few dozen vehicles a day. And they were also associated with historic road mortality, as we've seen with the kernel density estimates. Now, in summary, mitigation on Highway 64, we have seen that there's a historic concentration of collisions through these hotspots. We have about 2.3 times more red wolves hit than you would expect if red wolf mortality would not be influenced by traffic volume. This is also where we have most current as well as historic road mortality, and where we can be relatively efficient, also economically efficient with implementing mitigation. On the other hand, it's only 25% of all known historic road mortality, and it does not connect to high quality habitat as indicated through historic birth locations. Nonetheless, mitigating Highway 64 is of the immediate conservation concern. If we don't protect the last remaining breeding pair and their offspring, we can't have any success into the future. What about the low volume roads? It's clear that we can't really ignore them if we are to have the population rebound partially through reducing direct road mortality. This is where historically 73% of all collisions have happened. We have concentrations of collisions. We have historic breeding pairs and their offspring that we could protect, and also high quality habitat associated with it. But our mitigation efforts only have proportional returns on our investment, not disproportional returns like we have with US 64. And it is also not where we have current breeding red wolves. Nonetheless, mitigating these low volume roads is important once the population starts to grow again. In other words, we're not done with just Highway 64. Now, what does mitigation look like for red wolf? We not only looked at the biological characteristics of red wolf, we also looked at the other large mammal species that are present or could potentially be present in the area, because it's not just about red wolves, not just about one species in the ecosystem. Where we get to is metal post, chain link fence, pretty tall and overhang. Same approach. What species do we have or potentially have in the area that we want to get to the other side of the road safely? What does that tell us about the type and dimension of structures? We get to large mammal underpasses, elevated road sections, and wildlife overpasses, such as the ones shown on the right-hand side. Now, in this area, it's relatively flat, high water table, similar to South Florida, and this is where these images come from. And because many of the roads have canals associated with them, we might also have to build bridges over canals so that the animals actually can get to the wildlife crossing structures. If you're interested in red wolf conservation, the thinking, the strategizing, I encourage you to attend Travis Wilson's talk tomorrow morning. And with that, I thank everyone who has contributed to this project, and I think I have a few minutes. Thank you.
Are there some questions?
Hi, thanks for a great talk. I was wondering, maybe I missed it, how do you define historic, and how, and then with shifting mosaics, like if natural habitat is not the same natural habitat that it was historically, how do you kind of like shift those interpretations also?
Okay, so the question is, how do you define historic habitat or historic birth locations, or historic birth locations? So that is for the last few decades. Since the reintroduction started, 1987 in this area, this is when red wolves started to be born in the area. So that is what is behind the concentration of birth locations. And we didn't measure any habitat per se. We used the presence, absence, the number of concentrations of birth locations as an indicator of habitat quality over the last couple of decades. So that is how that is done.
Question?
So the habitats have changed, like the birthing habitats have changed over the past couple of decades. Is there any idea why they've changed, and how long have the current hotspots been actively used by red wolves?
So there was changes over the last few decades in where we're hitting red wolves. This is true. This is largely associated with how many red wolves do we have and where do they live, rather than major changes in the landscape. So that was the most important factor, how many red wolves are alive, and that leads to logical conclusions as to where they're hit.
Marcel, I'm going to take the moderator's prerogative. Is there any role for thinking about closing any of those low volume roads?
This is a very good question. Closing low volume roads. If you do not have vehicles driving on roads, you can't hit them with your vehicle. It's a very logical question. Now, there's always interest in people that want to use these roads, however low the volume is. There's always opposed with by stakeholders. It's taking away their freedom, right? This is how we used to think about roads. But it is a very effective, cost-effective way to reduce the road mortality. And you could argue that you can make a case for it. And we do not, as a society at large, have to have access everywhere all the time. Thank you.
Any other questions?
I was wondering if you could elaborate a little bit more about the population, or what caused the population shift from around 100 individuals down to the levels you're seeing right now?
So the question relates to what caused the population decline between 2013 and about 5-6 years ago. This is really not my role to answer. This gets political, but it was politics telling U.S. Fish and Wildlife Service what they could no longer do.
Thank you. It seems like there's some pretty important factors to be taking into consideration beyond hotspots. And my question is, across the country, as we are deciding where to put or recommend wildlife accommodations, do you think that there are enough studies on a big scale that are incorporating different factors? You know, I'm in Montana, so we're not just thinking about wolves, but we're thinking about a wide range of species. And I know we are overlaying models of connectivity. But are there any trends you see, and do you have any recommendations on, like, if you zoom out on how to make sure that we're taking into account these other factors?
Yeah, the question relates to, is there any other parameter besides road mortality on which to base mitigation measures, especially when you're dealing with multiple species? Yes, absolutely. If we only focus on mitigating where we hit animals, especially large animals, ungulates, they're common. This is historically where we've been most active from a human safety perspective. They are large and they're abundant, and we hit them frequently. They're a danger to our safety. Now, that is not sufficient. One, we're also hitting small animals, and we're also hitting large animals that are rare. So small animal species and large animals that are rare are not influencing the data on where you would locate your mitigation measures for human safety. So there's a huge bias in our culture, agency culture, is prioritizing human safety. I'm not saying it's bad. I'm just arguing for a two-track system rather than one-track system that is only rooted in human safety. I think develop a separate track that's based on conservation, and not just where we hit animals and kill them, but also what we need for connectivity. And it may even mean that we need mitigation most where we do not have road mortality because animals shy away from the road, the barrier effect is too great, or we may not even have that species be present in the landscape now, but where we want to have them be present in the future again, through reintroduction, for example. And you can be anticipatory with your mitigation measures rather than mostly reactionary. So thank you for that question.
Thank you, Marcel.
Thank you.